Okie dokie. Now let's talk graphing absolute value inequalities. So how about something like y is less than or equal to the absolute value of x. Let's start with the most simple one right there, because you already know what that graph looks like. So when we first begin to do these, we're first just going to treat this as if it were an equality and just graph that. So we know that y equals absolute value of x is the graph that looks like this. Done. Okay? Now, there's two ways you can draw this: a solid line or a dashed line. We draw a solid line because we actually have equals to in our equation. If this were just y is less than x, then it would just be a dashed line. Because this is saying, as it stands right now, this is saying that y will also equal any values on that line. This is saying that y will also equal some values off the line because it will be the only thing that's less than that. So once we have our graph, how do we determine what else is included in this equation beyond the standard graph? Okay. Well, the easiest way is to simply pick a point. And you can take a stab at something here, but we're going to pick 2 points so you can see really what's going on. I'm going to pick this point right there, okay? And let's, I don't know what that is, 1, 2, 3, 4, 5. Let's pick the point 1, 5. 1, comma, 5. And let's pick a point down here somewhere. Let's over here. Let's pick the point 2, minus 3. 2, or minus 2 rather. Minus 3. There we go. Now the point is you want to pick a point that's not on your graph. That's why I made sure to go way up here and then of course come down here. Pick any point not on your graph. So to find out what else is included in our graph here because of our inequality, we just need to see which of these 2 points actually is true if I plug it back into that equation. So let's get 1, 5. If y is less than or equal to x, is it true that y, which is 5 in this case, is less than or equal to the absolute value of 1? So if x is 1, y is 5, is this statement true? And clearly it's not, because 5 is not less than the absolute value of 1, or simply not less than 1. So that's out. So let's try this one. Is it true that y minus 3 is less than or equal to the absolute value of minus 2? So again, there's my x value, there's my y value. Is this statement true? Well, sure it is, because minus 3 is indeed less than or equal to the absolute value of minus 2, which is 2. That is true. So that means not only because of my equality do I get my graph y equals root x, but also I can now include everything below this line. So all of this data down here. Any one of these points down here below this line will make this statement true. Any point above here will make that statement untrue. So we're interested, of course, what makes a statement true. So everything below that line. So the answer there would be the line itself and the shading below the line. All right. And you're thinking, is it really just that simple? Yeah, it is. Once you know how to graph absolute value equations, and if you watch my first video, you know how to do that, then now it's just a matter of picking a point and seeing what works and what doesn't. Okay? Let's try another one. Let's say y is less than, or let's go greater than or equal to, let's say absolute value of x plus 2 minus 3. All right. So first thing I want to do is graph that. And I know then that this graph will be at minus 2, bump, bump, minus 3, bump, bump, bump. It'll go like that. It's going to go whoop, whoop. I'm just going to plot, I'm going to figure out this point right here when x is 0. That's 1. This goes like that. This goes like that. So there's my graph. And again, because it's an equal sign, I make it a solid line. Now it's just a matter of what else is included because of my greater than symbol. You can probably make a guess here that it's going to be everything above the line because it's greater than. But let's not assume at this point. So let's pick a point that we know is up here. How about minus 2, 4? And let's pick a point we know is down here. How about minus, or 3, 3? How does that sound? So we have 2 points, minus 2, 4, and 3, minus 3. Okay? And let's plug them back into our original equation and see which one of these statements, which one of these points makes that equation true. So let's start with this one. So when y is minus 3, is minus 3 greater than or equal to, x is 3 in our case, 3 plus 2 minus 3. Well, let's see, minus 3 should be greater or equal than 3 plus 2 is 5. The absolute value of 5 is 5. 5 minus 3 is 2. Is minus 3 greater than or equal to 2? It is not. Right? Let's try this one. Minus 2. Is it true when y is 4, minus 2 plus 2 minus 3? Well, is it true that 4 is greater than or equal to minus 2 plus 2, which is 0? The absolute value of 0 is 0. 0 minus 3 is minus 3. Is that true? Yes, it is. So that means that every point above the line, all the little guys that hang out with this fellow, are part of my solution set, and every point below the line is not. All right. That's pretty easy, huh? So let's try one where we don't have an equal sign. For instance, let us graph y is greater than 2 times x. I'm going to go with plus 2. Yeah, I already used that. I'll use it again. Plus 4. There we go. Let's do that. All right. Now I want to graph this so I know the 2 there compresses it a bit. It's going to go up a little steeper than it might normally. It's going to increase twice as fast at that point. And it's going to go up 4 and to the left 2. Left 2, up 4. Left 2, up 4. So let's go left 2. Boom, 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 up 4. 1, 2, 3, 4. And there we go. Now, this is going to increase a little more quickly. So I'll just, but the point is, because this does not have an equal sign, it's simply greater than, then we draw a dashed line. This shows that our solution set does not include the line itself, but it will still include any other values that make this statement true. And you've probably figured out already how this works for the most part. So let's just go with one point, and pick a point that it's going to be pretty easy to work with, really. Okay? I'm going to pick this point right here, our good old origin. Yeah, there we go. That is clearly not on my graph, so I just need to know, does this make this statement true or not? The point 0, 0. Well, let's see. When y equals 0, is 0 greater than 2 times 0 plus 2 plus 4? Well, 0 is greater than 2 times 2 plus 4. That means, is 0 greater than 4 plus 4, or 8? Is that true? It is not. Right? that means every point down here is not part of my solution, which means every point up there is. And you're thinking, oh, wait a minute. I don't trust my math skills. How do I, just because that doesn't work, how do I know all those do? Well, you should trust yourself. But let's test it. Let's pick a point up here. How about -2, 7? That's clearly not on my graph, right? Yeah. So let's plug it in, see if it works. -2, 7. I'll just do that over here. So if y is 7 greater than 2 minus 2 plus 2 plus 4, is it true that 7 is greater than -2 plus 2 is 0, 2 times 0 is 0, this is just 4. Yes, that is true. Done. Boom. Yeah. So you just need to pick one point. You just need to know where it's true and where it's not. Yeah. All right. Yeah. The hard part really was learning how to graph those things. Once you got that inequality, that's just window dressing. Okay. Thank you.